Math 242, Quest to College. I'm Joe Vasta, and we are going to cover section 8.7 out of our book, Systems of Nonlinear Equations and Inequalities. So all of our problems are going to have us solve, meaning find all the solutions to nonlinear equations and inequalities. Nonlinear means that now we're not working with lines anymore. We are working with curvy things. So these are curvy things. And so some of you might go, oh, I recognize these graphs. We'll get into the graphs of these, but for now I think I want to focus in on the algebra as we start this problem. So how would I solve for the variables with their squareds there? Well, one way is to use elimination. So I can actually eliminate the y squared by putting opposites for their coefficients. See, I have a 4y squared down there, and it would be great if I had a negative 4y squared. So why don't we just multiply the top equation by a negative 4? What we're not going to do, we are not going to use augmented matrices and doing things like that, because that works for linear equations. So let's write out these two equations again. Negative 4x squared plus 4y squared equals negative 4. And the bottom equation just stays the same. Okay, so that was bad. So I should have multiplied by a positive 4. Okay, let's get the white out. It solves all my problems. No one would even suspect anything happened. So this is a negative. Okay, so at this point, I'm asking myself, should I start this video again? And the answer to that question is no. This is going to be, oh come on, white out. Okay, so I multiply it by 4. Okay, so 4x squared minus 4y squared. And then we have this equals a positive 4. I'll just put a positive there. Okay, so it just goes to show you that we all make mistakes. So what do I have here? When I add those equations together, those guys are out of there. They cancel. And that was the whole idea of multiplying it by a 4. Let's go fix this up here. So I get 7x squared equals a 16. I'm going to solve for x squared by dividing both sides by 7. I have 16 over 7. And then I'm going to use the square root property, which gives me x equals plus or minus root 16 over 7. So let's bring this up here. This is going to give me two x values. And square root of 16 we can actually write as 4. So this is going to give me x equals 4 over root 7. And then x equals negative 4 over root 7. So how am I going to finish off this problem? I'm going to plug x into one of these equations. And the good rule of thumb is to plug it into the simpler equation, the one that looks a little simpler, smaller numbers, maybe this top equation here. So this says x squared, that's this guy, squared, which we actually could have just used that, minus y squared equals 1. So I have 16 over 7. I'll bring the 1 to the left-hand side, so minus 1, and this equals y squared. So 16 over 7 minus 7 over 7 gives me 9 over 7. And that equals y squared. I'm changing things around as I'm talking here. Square root property. This gives me y equals plus or minus the square root of 9 over 7, which is really plus or minus 3 over the square root of 7. So this x value yielded two y values. And so right now I've got a set of a few points. The first point being 4 over root 7, comma, 3 over root 7. And then the next one being 4 over root 7, negative 3 over root 7. Okay, so we got 2 points that satisfy these 2 equations from that x value. Now I'm going to use this x value. I'll put a circle around it because there's a circle around that one. Why not? And then we're going to plug that into, I know there's a lot of arrows going here, into the same equation. Now we can plug it into the bottom one if we want, but let's just do this again. This is negative 4 over the square root of 7, quantity squared minus y squared equals 1. So I square that, that's going to give me 16 over 7 minus y squared equals 1. This is the same thing that we have over here. I mean, so it's the same stuff that happens. So just look over to the left side. You would end up getting a y squared on the right hand side and 16 over 7 minus 1. So when all is done, you can walk through that if you don't believe me, you end up getting y equals plus or minus 3 over root 7. So this one gives me that there. And now I've got 2 more points. 2 more points being the x value being negative 4 over root 7, comma, 3 over root 7. And then the next point being negative 4 over root 7, negative 3 over root 7. Whew. So that gives me 4 solutions, which is weird because when we just had systems of linear equations, we said this, that you could have no solution, 1 solution, or infinitely many solutions. But when you have nonlinear equations, then you can have something weird like 4 solutions. Okay, we're going to take out a piece of paper here, and really if we were truly accurate, we could then plug each of these into the other equation to make sure we don't get any contradictions. What's going to happen in your homework is they're going to give you things that happen to be symmetric about the origin. And so you're not going to get as tough of problems as I've seen in other pre-calculus books. But nevertheless, let's show you a few things. These solutions here, even though there's 4 of them, if you wanted to be lazy, you can actually put them all together by going plus minus 4 root 7, comma, plus minus 3 root 7. And so that's another way you can write your answer. You can write your answer like this up here. You can write it like that. And this just means 4 points. It's the plus 4 over root 7 plus 3 over root 7. That's the first one. And then plus 4 over root 7 minus 3 over root 7. And it describes all 4 of them. Now you can't always do that, but in this case we can. So what have we got here? I mean, what is this really? Well, let's go ahead and see. Maybe I should just do this. Okay. I've got some graphs here. And we're kind of done with this problem, but I'm going to show you what we really did visually. So here's x, and here's y. I'm going to graph the bottom one first. This bottom one is 3x squared plus 4y squared equals 12. If you divide everything by 12, you see that bottom one, let me just write this out here, 3x squared plus 4y squared equals 12. This is an ellipse. Now, I know we went over ellipses in this class, but the quick way of getting this ellipse is finding the x-intercepts. You set y equal to 0, and you end up getting, so I'll just do this quickly, x-intercepts, you set y equal to 0, so you have 3x squared equals 12, x squared equals 4, x equals plus or minus 2. And to find the y-intercepts, you set x equal to 0, and you have 4y squared equals 12, y squared equals 3, y equals plus or minus the square root of 3. So you've got The x-intercepts are right here. And because I don't have to find all that other stuff, I see that square root of 3 is less than 2, so it's actually going to be an ellipse. Here's 2 right there. Well, it's probably like right there. It's going to look like this. Oops, I don't want to go too high here. Okay, this is just a rough sketch to show you what the geometry behind what we did. This guy right here, the x squared minus y squared equals 1, is a hyperbola. Now I'm not going to draw the asymptotes and all that stuff. We'll just make a really sloppy picture. The x-intercept, you set y equal to 0, you get, for the x-intercept, plus or minus 1. So those are the x-intercepts. So we kind of already know which way this is going to open because you have an intercept there and an intercept there. It's centered at 0, 0. It's going to open left, right. If you go to find the y-intercepts and you set x equal to 0, you get y squared equals negative 1, y equals plus or minus an imaginary number, so you're not going to have y-intercepts. So if you graph this one, without doing the official guide rectangle, you end up getting that. So you've got 2 graphs. You have an ellipse and a hyperbola. How many points of intersection are there? Why, there are 4 points of intersection. And those are the 4 points that I have. I know it looks like there are 6 points, but I was just doing the x-intercepts. So this one right here must be 4 over root 7, comma 3 over root 7. And then this one is 4 over root 7, negative 3 over root 7, and you can label the other ones as well. So this picture verifies that there are 4 solutions, which we got here, and some of you may prefer to write the solutions like that. Let's go ahead and do the next problem. So in your homework, we're going to be solving these algebraically when you have 2 nonlinear equations. So let's go ahead and do this one. It looks like I have the same ellipse that I had from problem number 1, but this guy right here is a circle. So let's do elimination, and I'll try not to mess this up. I'm going to multiply the first equation by a negative 3 to get opposites on the x squared. So I have negative 3x squared minus 3y squared equals negative 3. And then the bottom one is 3x squared plus 4y squared equals 12. Okay, so what is going to happen with this? I'm going to add these up, just like I did on the other equation here, the other system. So those are out of there. We end up getting y squared equals 9. So this is y equals plus or minus 3. So let's take them up here. Y equals 3, y equals negative 3, just like we did with the other one. So remember, except I had the x's. Remember I had that x equals this and x equals that. I'll circle them. And I'm going to go ahead and put this in the simpler equation. So y equals 3, I have x squared plus 3 squared equals 1. X squared plus 9 equals 1. X squared equals negative 8. Square root property, x equals plus or minus, look at that. This right here is an imaginary number. And we are looking for real solutions, so this is a dead end. Now, you got to put y equals negative 3 into that top equation. I have x squared plus negative 3 quantity squared equals 1. I get x squared plus 9 equals 1. Same thing. We get x equals plus or minus square root of negative 8. This is another dead end. So what happens when you go to try to find a solution to a system of equations and you end up getting dead ends everywhere? Well, the answer then is no solution. We actually used the word inconsistent before. So this problem here is consistent, whereas this problem here is inconsistent. We also had words called independent and dependent, but we don't use those words with nonlinear systems. What does the picture look like? If you care, and some of you don't, so some of you are going to fast forward to the next problem on the video. The picture looks like this. We have 1, 1, 1. We have the ellipse that looks like this. Just trying to do it really quickly here. That's the bottom one. And then the circle is centered at 0, 0, has a radius of 1. I'll actually make that one in a different color, and I should have done different colors on the other one. And so when they ask you to solve a system and they say, hey, solve this system, they're saying, what are the common points that these guys touch? Okay, are there any common points? And the answer is no. I mean, my ellipse looks really sad, but they have no points in common. So this is how we do problem number 2, and sometimes you may get a no solution in your homework. Let's go ahead and do problem number 3. Problem number 3, I'm going to keep the ellipse again, and I'm going to change the circle so it's a little bigger. We're going to see what we get for the answer. Multiply the top equation. You want to get rid of one of these letters, x squared or y squared. I'm going to get rid of the x squared, and since I have squareds above and below, I can do elimination. I won't always be able to do elimination on nonlinear systems, and we'll get to problems like that. So I have negative 3x squared minus 3y squared equals negative 12. And the bottom we'll just leave alone. So when I add those together, the x squareds are out of there. I've just eliminated them. And what does y squared give us? Well, because we have a negative 3 and a positive 4, so that's a 1y squared, and then on the right-hand side, that is 0. So the next question you might ask is, can that happen? And the answer to that question, it just happened. I'm going to use the square root property, and I end up just getting y equals 0. I'm going to plug that back into the top equation, and I have x squared plus 0 squared equals 4. X squared equals 4, square root property. X equals plus or minus the square root of 4, which is 2. So it looks like what we got on this is 2 solutions. Your 2 solutions are 2, 0. Notice I put the x first and then the y, and then the other one is negative 2, 0. So for all you lazy people out there, it is, another way of writing this is plus or minus 2, 0. So both are acceptable. So this is this or that. Do we care about the picture? Maybe we do, maybe we don't. I'm going to put it anyway, okay? So once again, this is the good thing about videos. If you're in a face-to-face class, it's kind of hard to fast forward the teacher. So we have that ellipse I've been drawing again and again, which has x-intercepts of 2 and negative 2. And it looks like this. It looks something like that. So there's the ellipse. And then the circle is centered at 0, 0, has a radius of 2. And look at this. So if I had just drawn the picture first, I would have probably been able to figure out the intersection points. What are the intersection points? This guy right here, which is 2, 0. This guy right here, which is negative 2, 0. And so the picture kind of confirms our answer, that there are two solutions. Okay, so we've done 3 problems where we had systems of nonlinear equations, and we find all the common points they have. And in this last example, there were 2 common points. Well, in this section, they also have systems of nonlinear inequalities. And here's something to note when you're doing your homework. They'll put the equations in a grouping of problems earlier, and then they'll put the inequalities. Lots of times, if you're looking at the inequalities in your homework, there's a lot of them that will match up with the system. Okay? That won't always happen, but a lot of them it will happen. And so some of the work that we did on problem 3, we might use that when we're doing work on problem 4. So what is up with 4? The difference between 3 and 4 is, 3 has equal signs, and that's called a system of equations. And then 4 has inequality signs. This is called a system of inequalities. So we are supposed to solve this or find all the solutions. And the problem with inequalities is sometimes we can't just put nice answers like 2, 0 and -2, 0. Sometimes, lots of times, there will be infinitely many solutions, and they'll be like in crescent shape areas, or they'll be in weird shaped areas that is hard to describe that using algebra. So when you get a system of inequalities, our answer is not going to be a few points. Our answer is going to be a pretty picture. So that's what we're going to do. Be prepared to draw pictures. Okay, so that's the first thing to realize. And so my picture is going to go right here. This picture is going to represent the points that these guys have in common. So it's actually going to be almost the same picture that I just did when I drew the ellipse and the circle. But we're going to put some shading on that picture. Okay, so let's go ahead and do this part in blue. So when you have an inequality and you have to graph it, the first thing you want to do is change it to an equation and graph the equation. X squared plus y squared equals 4, which is a circle with center 0, 0 and radius 2. So that is what I'm going to draw. And once again, I mean, you could be looking back at the drawing that I did on the last problem. It'll be very similar. So I'm going to go ahead and draw this. Oh man, I'm not good at drawing circles today. Oh, that's better than nothing. Okay, now here's a few things we want to note. And I'm using pen, so this was actually risky what I did. This solution, there's 2 more things we have to do after we draw the graph. Is we have to figure out the shading. So there's going to be some shading, and sometimes the shading will be on the inside and sometimes it will be on the outside. So we have to shade this. So to figure it out, I pick a test point that is not on the curve. And so something that is not on the curve maybe would be 0, 0, or the point 2, 2, but you just pick something that is not on the, like we would not want to pick 0, 2. And I plug it into that inequality and I get 0 squared plus 0 squared is less than or equal to 4. 0 is less than or equal to 4. Is that true or false? Well, that happens to be true. 0 is less than 4. So if this was just the only one I was doing, x squared plus y squared is less than or equal to 4, I would then go ahead and color inside the circle. But I'm going to hold back on that. I'm just going to put green, that's not green, that's blue. I'm going to put blue arrows pointing on the inside. Now the other thing that I have to check before I move to the next graph is this. This says less than or equal to, so the solution can actually be on the circle. And so if it includes the equal sign, then it's going to be a solid curve like I have there. The other one does not include an equal sign, so that's going to not be a solid curve, but it's going to be a dashed curve. So one of the first things we could have done is we could have said this one's going to be a solid graph, and then the one down here is going to be a dashed graph. Okay, so maybe I'll make this one in red. This would be a dashed graph. And so, let's go do the dashed graph. So we have 3x squared plus 4y squared equals 12. Now we've already found the intercepts earlier, and we found that the x-intercepts were 2, -2, and the y-intercepts, whatever they were, I think they were, I don't know where I drew this anymore. There was plus or minus √3, so we have something that looks like this. Now I'm going to draw the ellipse, but I'm going to draw the ellipse using dashes. Okay, so we have this right here. So there's the ellipse. Now I've got to pick a test point that is not on the ellipse. So test point, and usually the easiest test point to pick is 0, 0. Sometimes your curve goes through that and then you have to pick something else, but 0, 0 is on the inside. Oh, by the way, because I had true on that one, I go ahead and make the shading where it is true. One thing I failed to mention that if I had picked the point 2, 2 on the circle, I would have ended up getting 4 plus 4 is less than or equal to 4, so 8 is less than or equal to 4. So if I had picked this point for the circle, I would have ended up getting a false. So I pick a test point, and I'm either going to get a true or a false. I was not thinking because I heard the vacuum cleaner going, and I was thinking about vacuum cleaners. So sorry about that. Okay, so I put this test point into this inequality. So I have 3 times 0 squared, which is 0. And then I have 4 times 0 squared, so this is 0. 0 plus 0 is greater than 12. 0 is greater than 12. That happens to be, think about it for a few minutes, it happens to be false. 0 is not greater than 12, which means, see my ellipse there, it means I'm not going to be shading where 0, 0 is. I'm going to be shading on the other part outside. So I'm making little tiny red arrows pointing outside the ellipse. Okay, so this does look a little confusing, but let's go with this. In this picture, I'm shading inside the circle, but outside the ellipse. So where am I really shading? I'm shading on this part right here. And I'm also shading somewhere else. I'm shading this part right there. Okay, so we could emphasize our graph a little more by making it in black. That's a dotted line. That means there's no solutions right on that ellipse. But there are solutions on the circle. And when you have a boundary that's dashed that meets a solid boundary, you have an open circle at that point. So those should be open circles. And let's just go ahead and make the circle be darker. And so my answer then, let's go ahead and make the shading a little better. You know, when you go look back at the PDF on this, you're not going to be able to see my arrows. That could be a bad thing. That happens to be the solution to this. And you're like, what do you mean? All the part that has the shading and the solid lines, all those points will satisfy both of those inequalities. Now some of you might think, well, who cares? A lot of people care when they get to higher stuff, like you might be taking a game theory class. In a game theory, you study strategies that you can use to play games. And you have something, it's a magic carpet, I'll just call it, and it flies above this piece of paper. And you're trying to find the strategy, which is represented by the shading, that will optimize your chance of winning the game. Now, people who study economics, business majors, they all might be interested in game theory and optimizing their strategy so they can maximize their gains on their money. So that is the picture. These inequalities come with pictures. Okay, we'll do a few more of these as well. So let's go ahead and do another kind of example. We'll do example number 5. Example number 5 says we have these two equations. So we have a system of nonlinear equations. We know they're nonlinear because we see the squareds. This does look a little weird because it doesn't look like these will gel together. So what I'm going to do is I'm going to look at my y squareds and see that, wow, I could put opposites on those. For instance, watch this. I'm going to keep the top equation the way it is. I'm going to multiply the bottom equation by a -1. So I'm going to have negative 5x minus y squared equals a positive 2. I'm going to add those two equations together, and the y's are out of there. So we were able to do elimination even though this part is a little weird. Let's write that part down. This is an x plus 2 quantity squared minus 5x. This equals 6. Okay, I have to solve this equation for x. Let's go ahead and do that. I'm going to FOIL this out. So x plus 2 squared means x plus 2 times x plus 2. So this is x squared plus 2x plus 2x plus 4. Okay, so I just went ahead and expanded that. Minus 5x equals 6. So I have x squared minus x plus 4 equals 6. X squared minus x minus 2 equals 0. Sure hope I don't have to use the quadratic formula on this. Factors of 2 that subtract can give you 1. Okay, I can factor this. And so, oh, this pen is running out of ink. Do I have another black pen? Oops, here's my black pens here. Okay. So I have x, and let's see, I have a 1 and a 2. I want that to be negative and that to be positive. We can go ahead and multiply that out and see, yep, that gives me what I'm looking for. So this gives me x equals -1, x equals 2. Okay, let's put them up here. X equals -1, x equals 2. I'm going to go ahead and put -1 into the simplest equation. The simplest equation actually is the one where this x does not have a squared, so let's use that one. I have 5 times -1 plus y squared equals -2. -5 plus y squared equals -2. Y squared equals +3 by adding 5 to both sides. Square root property is going to say that y equals plus or minus the square root of 3. So this yields 2 points. They are -1 root 3, -1 minus root 3. -1 coming from the x up there. Okay, let's go ahead and do this. X equals 2 in this second equation here. So I have 5 times 2 plus y squared equals -2. 10 plus y squared equals -2. Y squared equals -12. Square root property tells me y gives me plus or minus the square root of, oh no, look at this, imaginary. There's a time and a place for imaginary numbers, and this is not a time and place because we're trying to find the real solution, so this right here is a dead end. Now, if I had a dead end here and a dead end here, we would say no solution. But there actually is a solution, and the solution is this right here. Now, if you're a lazy person, and I am a lazy person sometimes, we go -1 and we can go plus or minus the square root of 3. And that's another way of writing out both of those points. These two graphs intersect. They have 2 points of intersection. There they are. Now, the purist would go ahead and plug these 2 points into the other equation just to make sure they work. But in our homework, if you always pick the simplest equation, like this one was the simplest equation, especially when one's a function, you won't get extraneous solutions. But there are, times when you have nonlinear systems, and if you don't have as much symmetry, you'll end up getting these extra solutions, and you've got to make sure that they work. Another way is to graph these, and in fact, that's what I'm going to be doing on the next example. So you'll see the graph of these things, because I'm going to change these equal signs to inequality signs. So that will be problem number 6 when I get to it. So there it is. In fact, let's do number 6 now. Here's number 6. And it looks like, see, look, here's problem number 5. It's the same problem. In fact, my intersection points, it might be good to put them here. So it would be like -1 plus or minus √3. Those are our intersection points. So let's go ahead and do this problem here. And so look at this. This is kind of funny as well. Your homework, half of it's going to be, suited for the people who really like algebra. And then the other half of your homework problems, it's like an art class. It's something you might want to hang down on your refrigerator or not, because that does kind of look like an eye that's looking at you. It looks a little creepy, but maybe the next one will look nicer. So how am I going to do this problem? Wow. Let's go ahead and use different colors. Before I do that, let's put the picture right here. So yeah, that right there. Here's X, here's Y. We'll use blue for the first one. They are both solid. So this one's solid. And then this one is also solid. So we're going to have 2 solid lines. The first one looks like this. X plus 2 squared plus y squared equals 4. Well, now, does that look familiar? It should. It's a circle with center. So we remember this is going back to the conic sections. -2, 0. So -2, 0, which is like right there. Here's the center. And it has a radius of not 4, but it has a radius of 2. So it looks, let me go ahead and go like that. It looks like this. And it's a solid line, so let's see if I can make this where it looks kind of nice. Okay, so there's the circle. Solid. Let's do our test point. Test point. Lots of times we like to say 0, 0, but we can't because 0, 0 is on the circle. So let's do the point, maybe this point right here, which is 1, 0. Okay, so here's the test point, 1, 0. And we put 1 in for x, so I have 1 plus 2, that's 3 squared. And 0 in for y, and we got to be careful. I'm pointing here, but we're going up to this original thing. So we have the same thing on the left-hand side, and this is greater than or equal to 4. Okay, so this says 9 is greater than or equal to 4. Is that true or false? Well, that happens to be true. So that means this point right here is a solution, which means the solutions are inside or outside the circle. They are outside the circle. Had you picked maybe the point -2, 0, you would have ended up getting 0 is greater than or equal to 4. That would have been a false, and that would have told you shade outside the circle. So I'm going to go ahead and put little arrows, little blue arrows, telling me, hey, I want my shading outside the circle. Okay. Let's go ahead and do this one right here, which is also solid. 5x plus y squared equals -2. Okay, so what is this giving me? this gives me a y squared equals negative 5x minus 2. There's only one squared term, and this is going to be a parabola, and this parabola is not going to open up and down, it's going to open either left or right. I'm going to go ahead and try to put it in the standard form by factoring out a negative 5. Factor out a negative 5. I end up getting x plus 2/5. So the vertex happens to be negative 2/5, comma, 0, which is like right here. Here's the vertex. And this thing opens up. Remember we said 4p equals negative 5. This thing's going to open up to the left. And so when we do that, we are opening it up to the left. Now, so we're opening it up this way. We also see these points that have the square root of 3, and the square root of 3 is like 1.7. So it looks like, you know, you have negative 1, you know, positive 1.7, negative 1.7, and you're like, well, aren't you going to put the endpoints of the lattice rectum? I'm not going to be doing that, and I shouldn't even say that word, but we have solid. It's going to go like this. It's going to look like that. And now where are we going to shade on that? Well, this is where we do a test point. The test point is something that is not on that red parabola. I can actually make it 0, 0 now, and I put it back up here. So I end up getting 5 times 0 plus 0 squared is less than or equal to negative 2. Is 0 less than or equal to negative 2? Well, no, it's not. That's false. Think of the number line with negative 2 and 0 on it. So I'm not going to shade towards 0. I'm not going to shade to the right of the parabola. I'm going to shade to the left. So ultimately, now we're kind of done, almost. We just have to finish up our picture. Our shading is going to go to the left of that red parabola, but outside the circle, so our shading is going to go like right here. You know, maybe I should use, do I have, oh, here it is. I should use this right here. And then also I'm shading this right here. I got scolded in the 4th grade because I didn't color correctly. See, I had a teacher who was like, you were always supposed to color like this, like horizontal, and if you went like vertical and you did this, you got bad grade in coloring. And I remember her just ridiculing me in front of the class. Look at how Joey does it. He colors like this and goes all over, and I stayed inside the lines, but obviously she took out a magnifying glass and saw that my coloring wasn't consistent with the crayons. So yeah, I really liked school back then when that happened. And so what do we have here? Our solution looks like this. It's all, so when we're solving this, we're finding all the points that satisfy both of those inequalities. And so this is what it would look like. It would look like this. When a solid meets a solid, it's a closed circle, but you don't have to put it. Let's see if I can actually. You know, if you've had a few beers, then this is not a good thing to do. And I didn't, so I'm just in case you're wondering. There it is. So the solution is all that stuff, those solid lines and all that. And if you were doing economics or game theory, you'd be doing a multivariable function flying over that, and you'd be using your derivative guns to find where the mins and the maxes are. There's so much more to this than what we're doing in this class. But these are just some things you have to do, because you may have to do this in multivariable calculus when you're integrating over regions on the xy plane. Go ahead and do 2 more problems. I know some of you are like, these problems are just crazy. The first one's going to be very algebraic, and the second one's going to be picture-like. This one I actually would hang on the fridge. This one, I don't know. This would scare like visitors away, which maybe is a good thing. Okay, so I mean, maybe this is what we should wear when we're trying to do our social distancing. We'll wear that, like on shirts, and people will be like, oh, I'm going to just stay away from that guy. This one, I don't know. Something cool about that. Problem number 6. At any time, the camera is going to cut off because I just looked at the battery thing and it's flashing, so hopefully I don't continue to record as I'm speaking. Okay, look what I have here. I have a system of equations. It is nonlinear because of these squareds. And if you're thinking about, like, who should we eliminate? Like, if you wanted to just add this together and try to eliminate the y's, you can't, because this is a y squared, and this is just a negative y. So we cannot use elimination here. What we have to do is we have to solve for one of the letters in one of these equations, and then plug it into the other equation. The easiest letter to solve for is y in the bottom equation, because I don't have to divide by any numbers and get fractions. So what I have is I'm going to go 3x equals 10 plus y. And so 3x minus 10 equals y. Y equals 3x minus 10. So I've just solved for y. What am I going to do with that? I'm going to plug it into the other equation. Okay, so when I do that, everywhere there's a y, I replace it with 3x minus 10. And don't forget, there's a squared on that y. So it looks like what I have right here is a quadratic equation. X squared plus. Now, let me go ahead and write this out so you'll know that I'm doing a FOIL on that. So I have x squared plus first. Outside, inside, last. Okay, so I have 10x squared, and then this is going to be negative, I don't know what it's going to be, like negative 60x. And then I can subtract 100 on both sides. And so that's just going to zero out. I'm not going to have a constant. So I'm trying to solve for x. I'm going to factor out a 10 and maybe even an x. So I have an x minus 6. This equals 0. 10x equals 0. X minus 6 equals 0. So this one gives me x equals 0. And the other one gives me x equals 6. So now what I'm going to do is I'm going to go ahead and plug the 0. Now this is important here. You've got to plug it into the bottom equation because it's simpler. If you plug 0 into the top equation, you're going to end up getting extraneous solutions that will not satisfy the bottom equation. Since we're going to be taking a look at the picture of this on the next problem, you'll see how many solutions there are. Anyway, so I'm plugging this into the bottom equation. I'm going to get 3 times 0 minus y equals 10. So y equals negative 10. Plug in 6 into the bottom equation. I get 3 times 6 minus y equals 10. 18 minus y equals 10. Negative y equals negative 8. Y equals 8. Okay, so what have I just done? I went ahead and did this, and did that. So the first one yields a 0. That's the x value. Y value is negative 10. And the second one yields 6, comma 8. Those are the solutions. Once again, a purist would take those points and put them in each equation to make sure they satisfied each equation. So we could do that. I mean, look, here's x squared, so 0 squared plus a quantity negative 10 squared, so that's 100 plus 0 is 100, and then we have this, we have 0 minus a negative 10 is 10. And then we do the same thing up here. This is 36 plus 64 is 100, and then this right over here is 18 minus 8 is 10. So that's what a purist would do, especially when you're getting things that are a lot more complicated than what you see in the book. But we'll also verify there's two solutions by looking at the picture, because our last problem that we're going to do looks like this problem. We replaced these equal signs with inequalities, and they both say less than. So now we're going to turn to the art portion of this class. We know their intersection points are 0, negative 10, and 6, 8. Let's go ahead and graph a pretty picture and see what we get. Whoa! Okay, so already, see, I jinxed myself right when I said let's graph a pretty picture. That was it. What's happening to the y-axis? I don't know. Let's take this guy right here. We're going to write this as x squared plus y squared equals 100. This one happens to be dashed. It's a circle with center 0, 0, and radius is 10, not 100, so the center is 0, 0. So, okay, I think the battery just cut out, so put the other battery in there. Center 0, 0, radius 10, so our circle looks like this. It's a dashed line. You're probably wondering why I'm not doing tick marks. That's alright. So there it is. So this has radius 10. And I'm going to pick a test point that is not on the circle. So a test point, maybe our favorite one is 0, 0, and we plug that into the inequality. We end up getting 0 is less than 100. How did I get that? I got 0 squared plus 0 squared, which is 0. This happens to be true. So where's the shading going to go? The shading is going to go inside the circle. Okay, now let's go ahead and do the line. Oh, I just told you what it was. This guy right here is a line because it says 3x minus y equals 10. Now here's the sweet part. We can go ahead and do the slope in the intercept, but we got from the last problem that those 2 points were common to both of these graphs. And you can see, if you went and found the y-intercept, you set x equals 0, you'd get this point right here. And you can plot some more points. It's just a line. I'm going to plot the point 6, 8, which is like right there. This line is dashed. And so when you do this line here, you get that right there. Okay, so there's the line. I'm going to pick a test point that is not on the line. And so, once again, 0, 0 is always the popular one because it's easy to plug into inequalities. I end up getting 3 times 0 minus 0, less than 10. 0 is less than 10. That happens to be true. So what does that tell me? That tells me that the shading is going to go toward our test point 0, 0. And it looks like this. So we ask ourselves, hey, where are all the little arrows pointing? They're pointing inside the circle and to the left of the line. And so the shading is where all the arrows are pointing, which happens to be this region right here. have dashed line. When a dashed meets a dashed, you get an open circle, but when a dashed meets a dashed, you don't really have to put that open circle. It's implied. The only time you have to put an open circle is on boundaries is when a solid meets a dashed. That is the answer. And this graph happens to be a bounded solution because you can capture it like in a big basket. This solution here that we had on this one is unbounded, which means the solution set goes off to infinity. You cannot capture it in a box. It just keeps going off to infinity. And so that is, so you want me to put the open circles, I can. There's open circles there. That is how you do the systems of nonlinear equations and nonlinear inequalities. The equations yield a lot of algebra. The inequalities yield a lot of geometry in pictures. This is our last section that we're going to do in Chapter 8. Do your homework. Study hard. Have a good day.